Connected particles is a subtopic we are going to go through under forces and Newton's laws. So connected particles, two particles A and B, joined by a light, not this word light, inextensible string passing over, frictionless, not those three words. Light, inextensible, frictionlessly, I said to be connected particles. So let us see. If I have a string that is connecting these two particles A and B, so that it is passing over a pulley, but they are saying that pulley is frictionless. Now, you see that this particle, we say it's light, the string is light, so that the weight is negligible. Then inextensible, so that it's not elastic, so that it's firm. And then we are going to see that the moment, if these particles A and B are going to be, if they are weighing the same way, then there will be no acceleration. If the weight is the same, there will be balance. But if one is heavier than the other, then you are going to expect some movement. Now, look at this. If A mass is greater than B mass, it means that now this A, you see this A is going to pull because it's weighter than the other B, so it's going to pull, meaning there is going to be an acceleration which is going to occur in this direction. So, because this one is weighter, our acceleration is going to occur in that direction like that. After that, now, there we are going to be having action. Now, if this one is pulling, then the acceleration is going like this, but on this side, it's going to be like this. This one is going to be pulling as this one is moving up. So the acceleration to the right is going to be A. The acceleration to the left is going to be downwards. The acceleration to the right, this side is going to be upwards, then this one is going to be downwards. Once you know that, the acceleration or the movement of the particles is very crucial under connected particles. So, note tension T is the same without the string. So, this tension in the string is the same without the string. Acceleration always applied in the direction of a particle with more weight. So see that acceleration is applied in the direction of the particle with more weight. I think you see this one instead, it's weighter. Then another one is smooth surface means it has no friction. The surface has no friction. Then string is light, then the weight is negligible and inextensible, not elastic, or its size cannot change. Okay, let us see an example here. Two particles of mass 10 and 8 kilograms are connected by a light inextensible string, passing over a smooth pulley. If the particles hang free and released from rest, find part A, the acceleration of the two particles, then part B, the tension in the string. So start by doing a simple sketch. These are very easy things. So look at my sketch. Of course, I start by drawing where the pulley is going to be like this. Then you draw that this is going to be your pulley. Don't design. We are not in art. That's enough. That's my pulley. Then remember, there's going to be a string connecting two particles. So this is my particle. This is the string to one side, and I'm going to say now the string this side is going to have the weight or the mass of 10 kgs, 10 kilograms, like that. And then this side, I'm going to have a weight of, the mass, a particle of mass 8 kilograms. With this, you sketch neatly 8 kilograms. Then now, we say for anything which is having mass, it's going to be acting. It's going to be having its weight, which we say the weight mass. You see the mass is 10 times the gram, which is 10 g. Then this one is going to be having the force that's going to pull 8, which is going to be the weight, which is 8 times g. Now, because this one is weighter than this, it means that this one is going to pull. So it's that this tension is going to be having something that's pulling like that. And now, this tension is going to be, this kilogram, okay. This particle is going to be pulled, the tension is going to be pulled downwards like this. But remember, also there is some tension which is in the log that is going to be pulling up. So this tension is said it's the same. Then, this one is going to be having a tension that is being put, it's going to be having the force that is going to act downwards because of the weight, but also the tension on the screen is going to be pulling it up like that. So the tension there. Don't do this. Then some people are fond of doing this. This is wrong. What is this? You do like this, separate them properly. T, T, that's the tension of the string. Now, because this one is weight up, we are going to be having an acceleration, of course. This one can't put this one, because this one is weight up. So this now, the way this one is going to go. So meaning, the acceleration is going to be in this direction. So, as this one is going down, this one will be moving up. So, the acceleration of this particle is going to be going in that direction. While this one, because it's lighter, then the acceleration is going to be going in that direction like that. Because this one is always pulling, as simple as that. The acceleration is going to be the same. Now, after doing that, the rest is history. Because the rest we are just going to see how to resolve this and then how to get the resultant force of this and then the force acting on that. So from there we come to we start with this one, the 10 kilogram mass. Where is the acceleration? Acceleration is going downwards. So meaning our acceleration here is going downwards on this particle. So now remember our resultant force should be equal to the mass and the acceleration. Now what's the resultant force on this particle? It's going to be the force that is causing the acceleration, which is 10. You see, 10 is how much is pulling. So you have now 10g minus that which is opposing it. This thing which is opposing, that's pulling up, equaling to the mass. What is our mass of this particle? Is 10. Then times the acceleration of this particle, which is going to be a. And we call this equation 1 with ease. Then we come to the 8 kilogram mass. 8 kilogram mass. Where is the acceleration? It's now on this, the acceleration is upwards. So the acceleration here is upwards. So now meaning, what is pulling it upwards? Always the direction of the acceleration is very important. What is pulling it upwards is going to be T. So we have now Fr equaling to MA. The resultant is going to be now where it's going, the T, then minus the force which is opposing. This one is opposing, saying here I'm going down. So it's opposing, equaling to the mass of this particle, which is 8, then times the acceleration, which is A. They call this equation 2. I think from here you cannot fail to get T. You cannot fail to get A. How? You are going to solve simultaneously. Now, you see, I'm going to add equation 1 or equation 2 minus 1. Okay. This equation plus this equation 2 plus 1. Why? Because I have to get acceleration, so meaning I want to eliminate this T. But with this, the same side with this. I mean different side with this I add. So starting with the 2, which is T minus 8B equaling to 8A. Then this one I just rearrange. This equation 1, I start with this one, so negative T, then plus 10B equaling to 10A. Then I add. If I add, this will go to 0, this will go to 2G. I think a negative 8 plus 10G, you get 2G equaling to 8 plus 10, which is 18A. That our acceleration is going to be 2 over 18G. Which will now, if the question doesn't specify, you are free to leave it there. Or you know that our acceleration sometimes is taken to be 9.8. So here our acceleration, and this acceleration is going to be 2 over 18 times 9.8. So which would be, this will get 9.8 over 9 meters per second. That is going to be our acceleration. When I come now, if I want now to get the tension, this tension means that now I multiply here by 10, I multiply here by 8. So, meaning from here, if I have T equaling to 8, minus 8D equaling 8A, then I have negative T. So, meaning I want now to eliminate A. So, meaning I multiply this 10 here, multiply this 8 here so that I need the portion to be the same. Multiply we have 20, 88. Then this one will be T, 8B, 88. Then you do subtract y. They are having same signs. So this minus this, you get, I think it's this minus minus, you shall get 18t. This minus minus, you shall get minus 160b equal to 0. So our tension from here will be 160 over 18b, which you can easily put. Our t is going to be 160 times 9.8 over 18. Our t here is going to be, and easily simplify that. So this is going to be 784 over 9. And these are meters. And you have to be ready. Go. So here you earn all your marks. So that's it. We are going to see more examples about connected particles. See you there. Please don't forget to subscribe too.